Okay, so in the first video, we saw this problem, a telephone booth with Poisson distribution arrivals spaced 10 minutes apart on the average and exponential call lengths averaging 3 minutes. Under that, we saw the first sub question, that what is the probability that an arrival will have to wait more than 10 minutes before the phone is free. And we saw that this in this it is like finding the probability of waiting time is greater than 10 before the phone is free, that is what, excluding the service time. Okay, so for that we had that our formula number 8. Okay, so that is from w to infinity lambda 1 minus lambda by mu e raised to minus mu minus lambda into w dw. Okay, and this was for the excluding service time, and we solved it further. Okay, now the second sub question under 8 is, what is the probability that it will take in more than 10 minutes altogether to wait for the phone and complete the call. Okay, so see the difference between the first sub question and the second sub question. First sub question was asking for the arrival rate, sorry, asking for the probability of waiting time only in the queue. Okay, that is before the service is performed. The second one, here it is asking for the waiting time in the queue as well as the time required for the service, right? That is to wait for till the phone is free plus complete the call. Okay, so this is an example of finding the probability of waiting time is greater than 10 minutes, but this is for the including the service. Okay, now for including the service we have this formula number 9, that is probability waiting time is less greater than or equal to w including the service time. That is what, w to infinity mu minus lambda e raised to minus mu minus lambda w dw. Okay, so for this second sub question we will be using this formula number 9. Okay, in this we know the mu value, it will be 1 by 3 which we had found. Lambda we know 1 by 10. Okay, so we will substitute for all these values and we will integrate with respect to w, and then finally it will be what, we will put the limits from w to infinity. Now that w will be 10, so 10 to infinity. So for solving the second sub question we will use this formula number 9. Okay, so I'll just note down this for the solving the second sub question. Substitute in formula 9. This you will be able to do because it is only substitution and an integration, similar to the first sub question. Only thing is that the formula is changed. Okay, now so this one you will be able to get, and what you get the answer is e raised to minus 7 by 3. Okay, as the answer, and this I give just because for verifying. Okay, now let's move to the third sub question. What it says that estimate the fraction of the day that the phone will be in use. Okay, so that time of the day, or the fraction of the day that the phone will be in use. Now the phone is in use, that means what, the phone is busy. So that is what, any customer who is coming there will have to wait when the phone is busy. Yes, or better is that the phone, it is asking the phone will be in use. The fraction of the day when the phone will be is in use means what, the fraction of the day for which the phone is busy. Okay, that is what, phone is my server. Okay, since making a call is a service, so phone is my server. So we have the formula for this. Okay, the very first formula, probability that the customer has to wait or the server is busy. Sorry, this one. Okay, that is what, probability that the server is busy is given by lambda by mu, that is equal to rho. So we know lambda value, we know mu value. So it will be what? For the third question, what we need to calculate? Probability that the server is busy. So that is given by lambda by mu. And what is my lambda? I know what is lambda. Lambda is 1 by 10. Mu is what? 1 by 3. So it comes to 3 by 10. So this is the or 0.3, that this is the probability that the server will be busy or the phone will be in use. Okay. Okay. So this one is fine. Then this last sub question, that is what it says: find the average number of units in the system. Okay, now average number of units in the system is means what? Average number of units means what? The size. So that is what? The size of the system. Now for this we have the formula. Uh, yes, we have this formula number 4. Expected or the average number of customers or units in the system denoted by LS. Okay, so we will use this one for the fourth sub question. We will use this fourth formula, that is the average number of units in the system. Okay, so it will be given by, so how I will solve this fourth sub question, it will be what? LS I need to calculate, that is what? Rho upon 1 minus rho. Now we know what is rho. Rho is what? Lambda by mu. What is lambda by mu? It's 3 by 10. This we had just seen. So my LS will be 3 by 10 upon 1 minus 3 by 10. So this comes out to be 3 by 7 units. Okay. That is what? There are three on an average, there are 3 by 7 units in the system. Okay, so this is just about the substitution and in the formula, and so simplifying it. So you have more 4 problems of this model. This model is with the infinite capacity. Okay, so 4 problems of this model, that is altogether total 5 problems. Okay, this you will include into the journal. These 4 problems are sent in the group in the PDF format. Those problems you will solve and write the answers, and then after those 4 problems you will move to your model 2. Okay, sorry, after those 5 problems, the one which I had solved and the other 4, you will move to this, that is model number 2. And what is that? MM1 with my finite capacity with first come first serve. Okay, so it is similar. Only thing is that you have some few formulas. Only the formulas are changing. The formula of probability of having n customers in the queue is changed. The expected number of units in the system, or the expected number of uh, people units in the queue, that is average queue length, has changed. Waiting time has changed, and nothing else. So there are some 5 formulas over here. One, two, three, four, 5. Okay, these 5 formulas I have sent as a PDF. There's nothing much difference into it. Only thing is that um, the problems under this will be solved using these formulas. Okay, nothing else. Now see, in this, the very first problem is of the train problem. You can refer to the PDF. Okay, the train problem, what does it says is that if the for a period of 2 hours in a day, trains arrive all the yard every 20 minutes, but the service time continued to remain 36 minutes, then for this period calculate the probability that the yard is empty and average length of the system An assumption is that the line capacity of the yard is limited to 4 trains. Okay, so that is what it is saying. The sentence at this point, that the yard capacity of yard is limited to 4 trains. This makes the problem of this model number 2. Okay, that the capacity, that is n is equals to 4. Rest all things are same. Only because of this sentence, this problem falls under this model number 2, and you will use the formulas which are over here. Okay, rest all your lambda is your arrival rate, mu is your departure rate, and all other things are one and the same. I have sent this, those 5 problems I have sent in the group. After that, in the same PDF, there are this model number 2, sorry, model number 2, and this MM1 with NFCFS, and these 5 formulas have been sent there. Okay, and similarly these problems are there in the book. It is just about the substitution in the formulas.